Hey, good afternoon. It is still July 17th, and I am still Rob, that developer dad. And this morning we started getting the LLM integration that we created yesterday more domain specific. And we got it working, so that's great, but that it kind of also gets us into a place where I start to have problems with MVP thinking. Like we can get a pretty sweet text description for our NPC that satisfies the MVP requirement, but it does itch my brain a little because it's one of the bigger problems I have with minimum viable product philosophy. It tends to be focused on getting results right now rather than doing things right. And when we know how to do things right the first time, we really ought to do those things right the first time. They save us a lot of pain and hassle and needless rework later on. So I could leave it as it is, but what if we need to alter the prompt? And what if we want to add more AI capabilities for other generation workloads in the NPC creator? What if we want to pull that AI workload subsystem into another application that has nothing to do with playing a D&D game? So what if instead we put a little more thought and work into it now so that we'd end up with an actual subsystem that we can define the workloads and all their necessary data externally and push those into the AI workload subsystem at runtime and then invoke them as needed? I think we can do it. We just need to think a little bit differently than we have been today and yesterday. So let's get started by sharing my screen. We'll go over to that. Here we go. I'm back. And I've actually got a document with some notes in it that tell me what we need to do. So right now, up in our AI or the LLM Access component down here, that developer dad.llm access project, we've got a contract called iPrompt execution. And okay, so we've got execute prompt async. It accepts a string that has our fully realized prompt, including any kind of template replacements and so on. And it returns a task with a string existing as the result. And that's pretty good. We've done some pretty cool stuff with it. And we could continue by adding more prompt builder functions outside and keep passing those in as we want. And that'd be great. But what if we want something a little bit more sophisticated? Because the semantic kernel isn't just about executing prompts against a check completion service or anything like that. It's also able to execute functions. And to do that, we need to be able to define a function to execute and then pass that into the kernel, which then does some magic and turns that function, which contains a prompt template and a description and a name, and then we give it kernel arguments, which is our data, and it takes all that stuff and it mixes it around in its internal mixing machine, throws the result of that mixing at the LLM, and then returns the result to us when it's ready. So what we want to do here is we want to define a function request and a function result up here in our contracts. So we're also going to need a function definition. So let's add some classes. First class we're going to add is a function request. And we'll make it public. Allows us to request that a function be executed by the semantic kernel. And let's save that for now. And I'm going to close our run workload request and response and the manager stuff. We also need a function response or a function result object. So let's add that class. Add a class called function. Let's call it function response. We'll make this public. Let's go ahead and add the constructor. We'll add an empty constructor now here. And our function request is going to need a function definition. So, public function definition. And I'm just going to call this the function. It's going to be a get and an init. And Azure AI, OpenAI already has a function definition object on it. And I don't want us tightly tied to that concept. So function definition, we can't use that. Instead of function definition, let's get rid of that reference. See you later. Let's call it semantic definition. I like that. That'll have to do. It's not perfect, but it's fine. So we're going to have to add a semantic definition class. Make it public. And there we go. And we better save everything just to make everything stop complaining. Here we go. Good. Now, we're going to want to define that semantic definition up here in the constructor. And we're going to want to pass it in because I've got it set up so that it can only be set at creation time. So let's say function, equals new semantic definition. Great. Save that. And so now we've got access to it. And we're also going to need to be able to pass the values. So for that, let's add a new public property, and it's going to be a dictionary of string for the key. It's just going to have some object for the values. We're going to call it parameters. Get init. And we better define that up here, parameters equals new dictionary of string and object. There we go. And that's about all we need here. So let's save that and we'll close it. What does our function response need? Well, right off the top, I think we want to include do we want to include the request in the response? I think we do. Public function request. We'll call it the request. And we're just going to make this fully read-only. Private set. Can't forget the semicolon. And that means we will require it on our constructor. So that means we're going to pass in a function request. And request equals request. Great. And finally, public string result. Yeah, we're going to make this get and set for now. We're also going to add public string array errors. Now, we're going to hold our errors as private read-only list of string errors. Errors equals a new list of string. Instead of request being a get private set, we're just going to turn that into a lambda function. Oh, not request. Don't want to do that. We want to do that with errors. And we're going to say equals errors.toArray. And then finally, we need a way to add our errors. And I like to put methods down below. Public void add error message string message errors.addMessage. Let's just add a little bit of syntactic sugar here. Public bool is successful. And it's successful if we don't have any errors. Let's save that. So our prompt execution, we can now add a new method to it. And it's going to be a task whose result is a function result response. And it's going to say execute function async, receive a function request, and there we go. Let's save that. So now we need to implement this over on our prompt execution thing. And prompt execution is a really crappy name for this. And iPrompt execution is a really crappy name for our interface. So I want to change the name of this to rename ILLM lowercase ILLM Provider. Boom. Yes. Let's change the name of that interface. And let's rename this from prompt execution to LLM Provider. And say yes. Now we need to add we already renamed. So let's do that. So here's execute function async. Now to execute a function against the semantic kernel, we obviously need a copy of the kernel, and we need to create what's called a semantic function. So to do that, let's do a little bit of internal conversion. Now the first thing, we obviously need to get a copy of our kernel. So we could just repeat all of this stuff, but then when we refactor this so that it's built from configuration, we're going to have to change that in a bunch of places. So rather than spin up a new class or a service or anything like that, let's set up a new region of our code, private methods, pound and region, private methods, and we're going to have a private kernel build kernel. And let's just do this. We'll copy this. Actually, we're just going to cut it. I'm going to paste it down here. Return the kernel. Great. Kernel equals build kernel. Not kernel, but kernel. Great. Good. So we need to do the same thing up here. Equals build kernel. Cool. Now we need the kernel to execute something. So to do that, we actually need a function. And the long and short of it, I've actually got an example of how this is done over here, and it's been a while since I've played with semantic kernel, so I need to refer to something before I start messing with this, or I'm just going to code myself in circles. And let's take a look here. Plugins, add from type, I don't care about that. Section, yeah, logger factory, create builder, edge, completion service, etc. Daily fact plugin. That's a kernel function. Kernel function factory is create from prompt. Function name, description. Execution settings is settings. Okay, good. So let's take a look at the code in this example page. And this was put together by a guy I know on LinkedIn who's been posting quite a bit lately, isn't it, about using semantic kernel. And what he's doing is he's creating a kernel function called daily fact, and we're going to piggyback on the concepts here. And these kernel functions all have a description, a template, a function name, and a plugin name. We're not going to deal with function or plugin names here. But you can see down below that we've got this kernel function declared, and it returns a task with a string in it. And it's get daily fact, description, current date, string today. So that describes the parameter, and it accepts an instance of the semantic kernel engine. And then it runs the module level function, invoke async, kernel, new stuff, today equals today, configure await false, all that stuff. And then it just two strings our result. So we're going to piggyback on this concept, and it creates, this is the function that's called down here in the get daily fact method. So we're going to use this kernel function factory create from prompt, because that's essentially what we're doing. So let's declare a new private variable down here. Or not a private variable, but a private method. And what's he declared that as? It's a kernel function. So we're going to call it private kernel function build function. We're going to accept our function request. Excuse me. And what we're going to do is string template equals request dot function dot, our function doesn't have anything in it. That doesn't help us at all. Oops. Ha! Oh, those darn remote desktop keyboard bindings are biting me in the butt again. So let's save this, and we know that function is of type semantic definition. And yep, lo and behold, we left it empty because we're silly. Let's add some properties to this class. Prop, string, every function needs a name. Prop, string, let's come back here. Description, prop, string, template. CTOR. And I'm just going to assign default like string.empty to these things. Name equals string.empty. Description equals string.empty. And template equals string.empty. Save that. What's different about my LLM provider over here? We'll add the documentation of that in a little bit. So we can come back over here and say string template function dot template string name equals request.function.name string description equals request.function.description. And that's really all we need to pull from there. We are going to need to pass some settings, and these are prompt settings. And this is something that's built into the semantic kernel. So prompt execution settings equals new anonymous thing. Let's give it a semicolon just to keep it from complaining at us. And then we need to add extension data equals a new dictionary that's keyed as a string. Its values are objects. We need to call the constructor, and then we're going to say temperature. And temperature controls the creativity of the typical LLM, and most large language models that are OpenAI similar or that support, excuse me, OpenAI's API have the same kinds of properties. The important one here is max tokens, and that lets us limit how large a response our language model will generate. And I've noticed that Phi-3 Mini can get kind of chatty. So I'm going to limit our response to 1,000 tokens for now. We might want to lower that. And later on, of course, we're going to make this configurable at both the component level so that we'll be able to set valid ranges for whatever model we're using. And we could even set it at the prompt definition level where we can vary our temperature, our max tokens, things like top P, top K, and you can Google those. We could set those at the function definition level as well once we abstract that stuff in. But for now, we're just going to hard code it. So we've got template, name, description, and then we are going to say KernelFunction, and I'm just going to call it func equals KernelFunction factory dot create from prompt. And we're going to pass in function name is name, description is description, execution settings is our settings variable. And the very first thing that we need to pass in is the prompt, or is the prompt template. There. And now we'll just return the func. To do. This is smelly. We ought to abstract this later. Let's save our work. All right, so theoretically, we can now instantiate our LLM provider with one of these guys Oh, execute function async. We're not actually doing anything yet. So var to execute equals, what did I call that private method down there? We got build kernel. Oh, that's execute prompt async. We don't need that. Build function. Request. Cool. Now our request also has parameters on it. And we're going to need to pass arguments when we invoke this function. So, but let's start off with var result equals, and I'm going to call this, I'm going to change this from result to function result. Just, oh, function. Oh, stop it. Function result equals to execute dot invoke async. We're going to pass the kernel. And then we also need to pass our arguments. And we don't have any arguments, do we? Arguments? What are? So I guess we better build our argument collection. Var arguments equals convert request params. Request. So let's push this down to the bottom. Copy. So we build our kernel, we build our function. Private kernel arguments. Let's paste in what we got there, and we're going to take our function request. Now we're always going to return kernel arguments, whether we've got anything in our parameters collection or not. So let's do that now. For each string argname in request.parameters.getKeys. Apparently getKeys doesn't exist. Ha! I know there's a method on here, .keys. It's just a property. And let's say if request.parameters argname does not equal null. We're only going to include it if the value is not null. Args dot, we've got for each. Do we have any special methods on here, or is it really just a wrapped up thing? Seems to just be a wrapped up thing. So we're going to say args.add, and it needs the arg name and the value. And then we're going to return our arguments. Now, an important thing to keep in mind, when we build our parameter collection, we're going to need to name these args, which means the keys to our parameters. They're going to need to match any of the replacement tokens that exist in our prompt. And we're going to get to that in just a second. But first, I want to finish up our execute function async. Now, right now, our function result is going to be a task of function result. So let's turn this into a public async. And we're going to await this. And our function result is going to be a semantic kernel function result. And I'm just going to call this variable the answer for now. Function result dot, not rendered prompt, metadata, rendered prompt, value type. Well, I think it's just get value. Boop. And that doesn't tell me anything. Type arguments for method function result dot get value cannot be inferred. Okay, fine. We're going to have to do a little bit of exploratory coding here. So the answer is going to be a function result. Just for laughs, let's convert it to a string. Get rid of that. And we can compress some of this stuff. So this is a range. This is act. But we have a return value that we need to send back. So function response equals new function response. And that requires our request right up front. Function response, return the response, and response dot result equals the answer. Now, all of this stuff in here, because we're calling out to an external service that we have no control over, we might get an error. We might get an exception. Something bad might happen. So when there is a chance of that, we want to tell the computer to try it. And if something bad happens, it's going to fall out to our exception block. And var message equals ex dot message dot Add error message, message. So now instead of propagating this exception all the way up our stack and crashing our application, we're going to be able to, where we're dealing with the function request, function response level, we're going to be able to just very quickly say, okay, well, we're going to do this, and is the response successful? Great. Hello, Extreme Gamer. I see you just popped into my chat a couple of minutes ago. How are you? I'm building dotNet code using that incorporates a local AI. I hope it's not too boring for you. So our software further out the stack is going to be able to look at whatever comes back from this execute function async call and tell if it was successful or not, or if there was an error or what have you, without muddying up the internal memory space of our program with exception information. So our LLM provider is now set up as best we guess to accept a definition for an AI function to run, and it's the parameters that we want to pass into that AI function, try and execute it, grab the answer, and send the result back to us. I'm going to drop a breakpoint there. We're not going to run it yet because we haven't actually set up anything to invoke this. So let's bring our Solution Explorer back out. And we're going to be doing this from the Workload Manager. And we've got this execute workload, run workload request, run workload response. Okay. I think instead of doing it this way, we should, I think, switch this up a little bit and add a new class called a function definition. Now we can do this here because we don't reference the semantic kernel down here. So we're not going to run into any kind of type collisions or any ambiguity there. Now, I don't like the name function definition here, so I'm going to change it to AI function definition. And it's going to have name. What are you doing? Public string name, get set. It's going to have a description, public string template, get set. Great. We need a constructor. String name, string description, string template, name equals name, description, template. Save that. And down here in the AI Workload Manager, we're going to add void register AI function. And that's going to take an AI function definition. And then we're going to have a task of AI function result execute function async. And it's going to take string function name and string arguments JSON. Arguments JSON? Nah, I don't like it. I don't like it at all. It'll do. It'll have to do. We do need to define an AI function result. Add class AI function result. Make it public. And public AI function definition. Function definition. And it's going to be a get private set. What's this complaining about? Yep, all right. CTOR result, AI function definition. I gotta spell it right. AI function definition. There we go. And public string AI response get set. Because ultimately the AI is going to be responding with a string. There's more advanced stuff where it might respond with something else, but it always just returns strings. And of course, private read-only list of string errors, just in case there's errors. We'll do that. Public string array errors gets errors.toArray. Public void add error string error and errors.add error. Good enough to start with. So we now have an AI function result coming out of execute function async. We pass in the name of the function and our stringified arguments. Our execute workload runs a workload request. This is going to go bye-bye. That's not something I want to take on yet. Let's delete that class. And we'll delete this class. See you later. So we've got our function definition, our function result, our workload manager, and now we have to implement this interface out here. Do it. Our LLM provider has all of this stuff. We also need private read-only dictionary string AI function definition functions. We need to set that up in our constructor equals new. Great. Describe NPC. All right. Execute function async. That doesn't help us. Run workload response. This we're going to rip out. Goodbye. Register AI function becomes functions AI function dot name equals AI function. Execute function async. I'm going to add a new folder called type converters because you'd think I could just var AI result equals LLM Provider dot execute function async and pass whatever, but we need a function request. And let's change this name to AI response. All right, so we're going to need a request. Var request equals new. Well, what's the type of that request? It needs to be a function request. Okay. Well, we can pass that, but now we need to set up our request. Request dot function dot name equals function name. And this is going to be a whole lot of repeated code whenever we need to deal with this stuff. But let's get our function definition. Var function definition equals functions function name. Great. And let's go this way. Funcdef dot name request dot function dot description is the funcdef dot description request dot function dot template equals funcdef dot template. And so now we need to set our parameters. Request dot parameters dot add. What's the parameter called? This is not a good place. Well, so that's not a fantastic place to be? We need to figure that out. So maybe instead of adding the arguments JSON on our thing, we should maybe pass a dictionary keyed on string of nullable objects called arguments. For each var entry in arguments, request dot function dot, nope, not function, but parameters dot add entry dot key entry dot value and value may be null there. Our parameters, that's a dictionary of what? Nullable object, or not a non-null object. Let's go ahead and make those nullable. Save. AI workload manager, execute function, async, da-da-da-da-da. We need to make this an async method. Add an await. Var AI, AI function result. And result equals new AI function result. It takes in our function definition. So that'll be funcdef. We need to set result dot AI response equal to AI result. And the AI result is something completely different. So AI result ACK dot result. And of course, our AI result also might have errors if AI result dot is successful is false. For each var error in AI result dot errors result dot add error. So we're mapping all of that stuff over, and then we can finally return our result. I am not in love with doing all of this stuff over and over and over again. I'm going to Control X that right up to the top. So we set up the request. Send the request to the LLM Provider. Process the result. Okay, so we're getting our AI workload manager is now able to execute a function that was defined outside of itself. We can also set up a function and register it with our provider. Now, what if somebody tries to execute a function that doesn't exist? That's not fantastic. So we'd better guard function exists. Now, what this means is instead of guard function exists, returning nothing or throwing an exception, I want it to return a function definition. Yep, AI function definition. Stored function equals guard function exists. So let's grab that. We'll come down to our private methods. Well, we don't have any private methods. Pound region, private functions, and region, private AI function definition of the nullable kind, string function name, if it contains the key, we're going to return it. Otherwise, we're going to return null. Up here where we're looking for it, if stored function is not equal to null. No, if stored function equals null, our AI function result, I made a mistake on this requiring the function definition. I shouldn't need it. We're going to provide an overload function definition. AI function definition needs to become nullable. Our errors become a new list of strings. We're going to add our error right here. What's that complaining about? AI response must contain a non-null value when exiting constructor. And AI response, you're about to become a nullable string. Okay. AI function result, not definition. There we go. Errors.add error. Okie dokie. All right, let's save everything. Out here in the workload manager, string error equals the requested function name is not registered. And we're going to return a new AI function result with that error. So we're going to bail as soon as possible. Otherwise, our function definition is going to be stored function. We know it's not null by now, so we could say use the null forgiving operator and carry on. So that means we've just created a scenario where what do you mean it doesn't execute? It doesn't include execute function async. Oh, because I changed the signature from bringing in a string to bringing in a dictionary of arguments. So let's copy that, go out here, and instead of accepting a string of arguments JSON, I'm bringing in a dictionary, save that. My mouse's battery has expired, so I'm going to be using my touchpad. Let's come up here. Do we have any errors? Doesn't look like it. So we've just set ourselves up so that we can delegate responsibility for creating these functions to something outside of the AI workload manager and outside of the LLM Access. But that means we now need to define this function somewhere else. And for now, I think a perfectly fine place to do that definition is out in our, not the LLM Access, but we can do this in the character workloads. Because our character workloads has knowledge of the AI workload manager and knows that it's going to need some function definitions. So inside character workloads, I'm just going to add a comment, register the describe NPC function with the LLM provider. I'm out of time for this afternoon. I've got some things to look after in real life. When we come back tomorrow, we're going to bring the describe NPC function definition up to the character workloads component, register it with the LLM provider as soon as we construct, and then we're going to test it. So until then, take care of yourselves, take breaks, drink water, eat food, touch grass if you have access to grass, and have a great evening. I'll see you all tomorrow morning.